In calculus, there are 5 common ways to work out the derivative to questions. 5 different ways to derive. The first I'm just calling the easier linear just because it's in a line. And this one you'll be using most of the time, where all you're doing, as you can see in my worked example, is you just times the power by the front coefficient and you drop it by 1. So 3x to the 4, you times the power by the front, so that's 12, and you drop the power by 1. Times the power by the coefficient, so it's minus 10, drop the power by 1, and so forth and so forth. If you have something like this here, and this, just to tease it out, 8x to the 1. If you times the power by the front, so you'd get 8, and you drop the power by 1, you end up with 0, and so it becomes 8 times 1, and that's why whenever you have an x term, it just becomes that number. It just becomes the coefficient. Ditto when you've got a constant term like minus 7, there's no x at the moment, so if we had to force an x into the 7, that's what it would have looked like. So if you times the power by the front, you end up with 0, and that's why constant terms won't have a term in the derivative. So that's the easier linear that you keep coming back to. The second type is brackets, which is dead easy because all you do is the trick is just to times everything out first, and then again you're back to the easier linear. Times the power by the front, drop it by 1. Times the power by the front, an x term just becomes a coefficient and a constant term falls away. The third type is surds, and for those the trick is to change it into exponent as quickly as you can. And so it's when you change it to an exponent, so let me just pick on this example, the last term here, it is always the power that it has over the rooting. That's how you change an exponent. That's how you change a surd to an exponent. It's the power it has divided by what it's rooted by. If I had a number in front, so something like this, then it would still be the 2, and then it would be x, and the power it has, 6, over what it's being rooted by. And then I will go back again to the first one, the easy linear, where I'll times the power by the front, drop it by 1. And with fractions, obviously ideally you'll be able to just take any fraction and minus 1. If in doubt, use your calculator to just minus 1 from it, because sometimes those powers get a little bit confusing. Last one of these in this video is if there's one term in the LCD. And if you find that a lot of people try and just cancel straight away what they can, or they try and do the first rule, times the power by the front, drop it by 1. But you need to make sure you separate them first. So I've put them each over x to the 4, and then you bring the x's up. So here I'm left with x to the 1. Here, when I bring the x's up, I end up with x minus 7x to the minus 3. And here, I end up with 3x to the minus 1. And again, I'm back to my normal steps of times the easy linear, times the power by the coefficient and drop the power by 1. And then typically you'll leave your answers, I would do this as a habit, leave your answers as a positive power. And so they go to the bottom. Be careful, you don't take the number, you don't take the coefficient with as well. It's just the x. For example, here, it's 21x to the minus 4. So it's only the x to the minus 4 that goes to the bottom. And that is an intro to different ways to derive.